The following content has been provided by RWTH Aachen University.
All right, so today, responsiveness and performance. This topic is taken from a book by Jeff Johnson, great guy, a friend of mine, and he's a wonderful researcher in HCI. He's written a couple of books called GUI Bloopers and Web Bloopers, and then he had to write GUI Bloopers 2.0, and he told me the other time at Kai, I'm never going to write a bloopers book again. We'll see about that. The book's wonderful because it has only bad user interfaces. Right? So you open this book up and you see like web UIs or like desktop UIs, and he points out the mistakes people made in those UIs, and you have a big laugh at it, and until you get to one page where you're like, oh, I did the same thing in my last interface that he's criticizing here. So it's a great book. Take a look at it if you're interested in that. And in that, he has a very insightful section on responsiveness. Responsiveness basically means how fast an interface reacts to what the user is doing. And it's not to be confused with performance. We'll get to that in a minute. But it is a big problem in interactive systems because if an interface isn't responsive, it doesn't give you feedback on what's happening in a timely fashion, you open up the gulf of evaluation that Norman talked about. A couple examples would be, you've probably been mousing around on your screen at one point, and your mouse pointer was starting to jump around, right? Because some operation was blocking the system in a really bad way. Or you click somewhere, and then for a second, nothing happens. Right? I get that on my navigation system in the car. You tap, and you're like, did it take it or not? And then after a second or so, it pops up. That's too long. Sliders and scroll bars that lag. So you drag, and it takes a while to scroll down. It's just annoying. And or applications that basically go dead while they're trying to save something to a disk or access some resource over the network. Or systems that repaint the screen several times. Again, my navigation system does that. It shows me a map, and I'm like, oh no, now it all goes away, and it builds it again with like one more piece in there. Very strange. And if you look at all these things, they sound like it's because the computer is too slow. But if we're honest, it's really because the programmer is too stupid, right? Because this has nothing to do with performance levels of computation and stuff that need like a megahertz or gigahertz CPU. This is stuff that is very easy to do in time if you program your software right. So a couple of reasons why this still happens. First of all, not a lot of people, especially in the software development community, know about the importance of responsive interfaces. The people who write the code basically think it's the same as performance. This is easily confused, although it really has almost nothing to do with the sheer performance of your hardware that you're using. It's mostly just smart software writing. And interface designers also tend to think of other things first. As an interface designer, you might take your golden rules and you say, like, OK, make sure that the button up there is always active so I can go back to that place and make sure we have consistent wording in the dial. You do all these wonderful things in your interface design, and you don't think about the temporal rollout of your interface. You don't think about how it behaves over time. For you, it's just a bunch of static screens where you move from one screen to the next. And you don't think about, when I move from one screen to the next, how is that going to look? How is that going to happen? What's supposed to be the constraint here, time-wise, in order for this to happen? So since it's rarely specified, programmers don't really think about it. But also, like I said, this isn't easy. This is where your software developer smarts really come in handy. Because writing good responsive code usually almost always means multi-threading at least. So you always have to make sure that you're processing your user interface responses in a separate loop in your application in some way from all the background operations. And that's easy to overlook if you're writing a simple system and you go and you have a lengthy operation, and that takes a little while, and you're like, it's not a big deal because it's only a fraction of a second. And then you process the next user interface input without going into a threading model. Then before you know it, your operation takes a little longer because the data that was supplied to it was much bigger than you anticipated, and that's your problem. Your interface hangs. There's also the a rule that my first computer science professor at the University of Karlsruhe, Walter Tichy, taught me in the software engineering lecture. He said, make it work first before you make it work fast. It's a common rule among software engineers. Make sure your algorithm is clean and correct first before you go into optimizing the heck out of it to make it faster. And that's a good rule. But if you stop at making it work and the performance of that algorithm somehow impacts the user interface, then you're not done. Right? You still need to go through and process that. I like to think of, to give you a picture of how important responsiveness is, essentially any computer system, any software and hardware system that you ever build that has some kind of user interface attached to it, where the user will get feedback, do input, is essentially a real-time system with hard constraints on the real-time performance. Now, I'm not talking about like, microsecond performance like you need for some technical processes, but milliseconds for sure. And a lot of people don't think about interactive software as real-time software, but it is. If you don't fulfill the real-time requirements that the user interface has, then your software isn't responsive and it will feel sluggish, laggy, just badly written. So take another look at real-time systems, and a lot of the stuff that's being researched and developed there applies to user interface software as well. A lot of people in the development community instead think of human input, typing just like input from a machine. Take the Unix system, for example. If you're aware of, familiar with the Unix system, you know that file input, basically everything's a file in Unix, right? You can even provide input to a command line tool in Unix, and the input can come from the terminal where you're typing, or it can come from a file. Right? The application doesn't really care, the simple command line tools at least. And that's a model that goes back to when the first time-sharing systems and basically the distributed file systems were being designed. Even the word teletype, TTY, that you see in a Unix command line often, that means that you are being looked at as a type, at a teletyping communication device when you're typing on your computer. So that's the view of the engineering department, so to say, on human input. And if that's the view, then you don't have these specific real-time requirements. Because a file doesn't care if it gets read a little more slowly, right? That's okay. Or a sender on the internet that has a delay, some latency in the network, it will just wait and buffer the data until it can send again. That's fine. The computer doesn't get angry or bored. But people don't like the latency, and then performance really suffers. And in this case, I'm talking about human performance with a computer system if the system has latency built in. Because of this rule, make it work first, then make it work fast, and then fix it in the next release, you often end up with simple, naive implementations. Like the example I just gave, where you go out and just perform a lengthy operation on disk or a sorting operation because you think, it's going to be fine, it's going to be fast enough, I don't need to worry about it. Even loading a picture, right? You're like, I can load a picture and then go back to processing user interface input. That's great as long as the picture is in memory or on your local SSD. But then maybe the system at some point is being evolved into a network system, and all of a sudden that picture you were loading is on a file server on the other end of the world. And then the delay becomes noticeable. And finally, we don't have really good tools for this. That's another problem. There is no button in Xcode, if you're programming on the Mac, that says, create a test for, or measure the real-time performance, the latency between a user input click and the system's response. It's not easily modeled in there. We have a lot of performance tweaking apps. We can see where time is being wasted in an application, which loops and which commands get executed most often. But that's a different story. That's performance. It's not responsiveness. And then there are limitations, of course, of anything that is online, right? Any web connection, any cloud storage service. We know that these things are slow. If you've ever, who's written documents on like Google Docs or some other kind of online web editing system? Basically everybody, right? And every now and then you have this like, now it's like, hanging there and not giving me feedback in the timely manner because something is going on with the network that the system can't really know, but it's designed in a way that it doesn't take good care of you while it's waiting for that resource to come back. So we know about the limitations of online applications, but still the systems often don't keep up. Here's a simple example. Let's say you're the designer. You say, I want a scroll bar in the system. You say, OK, dear developer, put a scroll bar into this user interface. Now the developer, or as a designer, won't say how exactly the scroll bar behaves. And there's two ways you can do a scroll bar. The normal way, if you like, the one that would be the most appropriate, is as you move the scroll bar, your content moves. Right? Today, 99% of all systems do that. But in the early days of computing, when GUIs just came around, or today when you go to a very low-powered system like an embedded microcontroller or something that has some kind of simple GUI, you often see scroll bars that you actually need to move to a particular location, then let go, and only then the system updates the screen once. Ever seen one of those? Yeah, every now and then. It's simply saving a lot of computation because you don't need to show the picture all the time as you move the scroll bar, you just do it once. Now, if you as a designer, interface designer, don't specify exactly how your scroll bar is supposed to work, then the developer will basically pick one for you. Right? And he's going to pick the one that is the most robust, that's most readily available in the UI toolkit, that he's used in his last project because he still has some code to reuse. But he probably won't be looking at the question, oh, the real-time updating scroll bar is the better one in terms of responsiveness, because that concept isn't that high in his list of priorities. And that's not something to blame people for, because if you're not trained in the concepts of user interface design, then you don't really think about this stuff. It's not that you don't know that if somebody told you a live scroll bar, what's better, a live scroll bar or one that only updates once, everybody would probably say, well, the live one is better. But it's not something people constantly have in the back of their head and think about while they're writing code. Just as an interface designer isn't somebody who's proficient with every nuance of C++ programming. Right? It's just different kinds of skill sets that need to come together to make really good code. So some strangely eternal facts. First of all, I already said responsiveness is not performance. Right? You can have a wonderfully responsive system on a 1 megahertz CPU. Not a problem at all. Right? Just as long as you write smart code. And in fact, resources in terms of processing will always be limited. Yes, we've seen a ginormous increase in computing power in our hardware over the last decades and so on. But you still, if you sit in front of your computer, the hourglass or whatever it looks like these days, spinning wheel of death, is still there a lot. Right? It doesn't seem like that it has really gone away that much. As I said, UIs are real-time systems with hard deadlines based on human cognition. And when I say human cognition, what am I referring to? What kind of deadline do we already know for human cognition? Yeah? Right, 100 milliseconds, a tenth of a second. That was the one we derived from which law? Bloch's law, right? Bloch's law. The delay between input and immediate first response, so to say. And we're going to look at that and other deadlines on the next slide. And this is something that is really important, and a lot of people, when they write code, don't think about it. If you write a piece of a program that is supposed to load a complex CAD drawing that the user is supposed to edit, you think the moment you start the loading routine, you have to load it all. You actually don't have to load it all at the same time. Because what's the next thing the user wants to do? They want to maybe look at an overview of the drawing. So you could probably leave out some details. So if your storage of your file is done in a smart way, you could only load part of the data at first. Or take the example of looking at a Word document. You load a Word document. The moment you say open document, it would technically probably be enough if the system loaded the first page and showed that to you right away. And then kept loading the rest while you have a chance to already start looking at the first page. So, and some of the things you might never have to do. If there is a big map that somebody wants to look at, and they only ever look in the right corner during the interaction, and you've held back on loading the lower left corner because it's not in the visible screen space, maybe you never need to load it. Right? So not everything needs to be done in a given order or instantly or maybe even at all. And that's something that is not easy for us to build into how we think about writing code, because we tend to think, oh, load the file, I'm going to load the file, all of it, so I'm prepared, it's all there. It's easy. That's what the typical library functions give you, the frameworks, right? But you don't always have to do that. So sometimes you need to splice up what you're doing in a task that is a little more time intensive and turn it into little chunks that can be done and then quickly return to the user interface so that you don't bog down the user.
This content was provided by RWTH Aachen University.